The book that we chose was Around the World in 80 Days. We chose this book because we believe it's an adventurous novel which engages students of the year level that we chose, which was Year 6.
The scene we've chosen to illustrate depicts the two characters once set off on their adventure, using the fire to make the balloon fly higher.
Whilst the size of our model is larger than it should be, we are happy with the outcome and the way that the systems work together.
As you can see, the wires are a completed circuit when all touching the conductive pop stick, which is in the middle of the box. However, on its lowest point of the cam mechanism, the lever disconnects the circuit by pushing the pop stick up from the connected wires. When the crank is rotated in a counterclockwise motion, the shaft is then rotated along with the cam, which pushes up the follower platform through the slide up to the second platform, which then rises the balloon.
The materials used in this model include dowel rods for the crank, the shafts and the lever, cardboard boxes as the base and the basket, balsa wood as the follower, the cam, hessian as the decoration, and twine, cellophane to represent the fire, a plastic cup to hold the light in the balloon, and paper mache with newspaper and PVA glue with obviously paint on top. The materials are joined usually by hot glue. The crank is made with hot glue joining the materials together. The cam and the follower with the follower shafts also have been glue gunned to secure. Same with the follower supporters with the straws, they're secured with glue gun. Fibre tape was used to secure the aluminium foil pop stick in the electrical circuit, and blue tape was used to hold the people in place.
Some of the challenges we had when making this model was with the weight of the balloon. The weight of the balloon with the paper mache connected to the basket ended up being too heavy for just one support attached to the follower, so we needed to back this up with 3 others. This ensured that the follower and the cam were strong enough to support the weight of the balloon. Another issue that we had was in ensuring that the cam was secure enough to the shaft to be able to take the weight also. So we enhanced it with extra pieces of balsa wood on both sides and then glued it to the shaft, which allowed it to be stronger as well. The weight also affected the shaft in general. It was hard to twist to begin with, so we built a crank in order to alleviate the pressure a little bit.
The relevant Australian curriculum links are: investigate how electrical energy can control movement, sound or light in a designed product or system. This is relevant to us as we are using an electrical circuit. Critique needs or opportunities for designing and investigate materials, components, tools, equipment and processes to achieve intended design solutions. This is relevant to us as we needed to investigate the materials that we were putting on our model to ensure that they were appropriate for what we wanted for our model. Select appropriate materials, components, tools, equipment and techniques and apply safe procedures to make design solutions. As said before, the materials were a very significant part. Also the joining techniques that we used are relevant to this link. Safety was also another thing that we thought about, and this is why we've glue gunned and taped the wires of the electrical circuit to the box. Develop project plans that include consideration of resources when making design solutions individually and collaboratively. This is relevant to us as we did a lot of planning before actually creating the model. We worked collaboratively throughout the whole project and used each other's strengths and weaknesses to complete this project.